Welcome back to Bartlett's Math Magicians. Today we're going to talk about multiplication. So here is our standard 5.NBT B5. So we're talking about multiplying multi-digit numbers using different strategies. So in fifth grade, the students are introduced to the standard algorithm, which is what most of us know as the traditional method of multiplication, or what some of us call the old school method of multiplication. Students in fourth grade learned the area model strategy and partial products. So I'm going to start with an area model because we want to start with concrete, pictorial, then move to abstract. And the standard algorithm is abstract. So we're going to start with 247 times 72. So I want to build an area model. So I want to create a model that will find the area having a length of 247 and a width of 72. So I want to try to draw them as close to scale as possible. So if this entire length is 247, I want to separate it by place value. I want to break apart the numbers. So I have 200 here, 40 here, and then we can say 7 right there. So the whole length is still 247. And then, so my width is 72. So I'm going to come over here, 70 and 2. All right. So now I have one large rectangle, but now I have broken them apart into 6 smaller rectangles. So I'm going to find the area of each individual rectangle. Then I can add all the areas back together to find the entire area of the box. So if I look at the large box here, 200, I know the area from third grade. Area is length times width. So I know that I need to multiply 200 times 70. And 200 times 70 is 14,000. 14,000. So I know a lot of people want to say it's 7 times 2, add 3 zeros. Well, yeah, there are 3 zeros, but we're not adding 3 zeros. We're actually doing, we can say we're doing 7 times 2 times 10 times 10 times 10. So it's 14,000. Then if I look here, the length is 40, the width is 70. So I'll multiply 40 times 70. That's going to give us 2,800. Then I have 7 times 70. That's going to give us 490. 200. So now I'm here in this little box rectangle here. So the length is 200, the width is 2. So 200 times 2, which is 400. And then I have the length here of 40. So if this is 40, that means this is 40 here. And then the width is 2. So 40 times 2, which is 80. And then 7 times 2 here, which is 14. So I've now found individual areas, and now I want to add them up to find the entire area. So I can add up 14,000. It's very important that I line up my place values correctly. So if I have poor handwriting, or if I'm afraid I'm going to get my place values confused, if I have a notebook paper, I can always turn my paper horizontally, and now my blue lines on my notebook paper now have created columns. 2,800, 490, 400, and I'm going to go ahead and combine 80 and 14 to have 94. So then I just add 4. 9 plus 9 is 18. 8 plus 1 is 9, plus 4 is 13, plus 4 more is 17. 4 plus 1 plus 2 is 7, and then 1. So 17,784. So this would be multiplying a multi-digit number using an area model. So the question is, why do we do an area model? Well, this is a perfect real world scenario if I'm trying to plot, if I'm trying to make a garden, or if I'm trying to build something and I need to find the area. This would be the length 247, width 72, and then let's just say if this is my whole entire plot of land and I want a section of part of it for a garden, part of it for building a playground. So I can find individual areas of my spaces, then add it up to find the entire area. So this would be adding with an area model. It's breaking our numbers apart by place value, so we can visually see what's happening when we break apart these numbers. So 247 times 72 is 17,784. I'm going to use the same problem for the next strategy, which will be partial products, in just a minute. But I want to do another area model using a different equation. So we're going to use a 3 by 3. So I'm going to say 224 times 126. So it's a 3 by 3. So I would still want to set it up the same way. So I need to have my 200, my 20, and my 4. Then I have my 100, my 20, and my 6. So we want to try to make it as even and as drawn to scale as possible. It's hard to get it perfect. We don't want to just draw lines like a graphic organizer. We want to draw it to scale so it kind of appears that way. So mine's not perfect, but it'll work. So then again, I want to find the areas of all of the rectangles. So this is 200 times 100. Which is 20,000. So I noticed a lot of the errors come here when we're multiplying by numbers that end in a lot of zeros. So I just got to think about if there are 4 zeros in my numbers, that means there's 4, 10 times, it's 10 times 10 times 10 times 10, which are, 10 to the 4th power, which is what we talked about earlier towards the beginning of the school year. So 20 times 100, which is 2,000. And then 4 times 100, which is 400. Then I have 200 times 20, which is 4,000. Then I have 200 times 6, which is 1,200. 20 times 20, which is 400. 4 times 20, which is 80. 4 times 6 is 24, which also makes sense that since this is the smallest value, it should be the smallest box. And then 20 times 6 is 120. So now I want to add up. So I can put this on my paper and add them all up, or I can start adding things that I notice. So right here, I know that 4,000 and 2,000 make 6,000. I know that 400 and 400 is 800. 80 plus 120, that makes 200. And then I have 1,200. And I'm going to add the 24. And then I have 20,000. And then I want to add all of that up. So that would be 4, 2, 8 plus 2 is 10, plus 2 more is 12. 6, 7, 8, 28,224. So how do I know that I'm right? Well, I can estimate before I solve, or even after I solve, I can estimate. So if I look at 224 times 126, I could round 224 to the nearest hundred, which is 200. And I can round 126 to the nearest hundred, which is 100. And then I can multiply the two together. And that would give me an estimate of 20,000. So my answer should be in the neighborhood of 20,000, which 28,000 is in the neighborhood. I could also round up. I could round both of these numbers up if I wanted to. Or I could estimate different ways. It just depends on what you want to do. But I can, so my answer is reasonable because 28,224 is close to 20,000. So that is multiplying using an area model.